last Tuesday we were doing 3.2. We learned how to find the zeros and the multiplicities of the zeros. So I'm going to continue from that one. So after the multiplicity, so we learned if the power of each factor, zeros, is the multiplicity of the zero. So for example, I'll just review quickly before I move on. So I suppose if I have f of x equal to x minus 1 square x plus 3 cube. So the zeros we already learned, so I'm just going to go really quick. So we have to find the zeros, we have to make this one equal to 0. And then you set each factor equal to 0 and solve for x. So that's how we get here x equals 1. Here we get x equals -3. And we have x equals 4. So these are the zeros of this function. To find the multiplicity, you just put the power. The multiplicity is 2 here because the power is 2. It repeats twice. And here it comes 3. So the multiplicity is 3. And it's 5 here, 5 here. If there is no power, the default number is 1. So this is how we find. Now, this multiplicity is even here, and these two are odd. So the next one, we're going to learn what happens to the graph if the zeros have even multiplicity. If this is even, then the graph touch the x-axis. Even means the graph touches the x-axis. At x equals 1 because the 0 is 1. If it is odd, this means that the graph crosses the x-axis. I will show you some example. The graph crosses the x-axis at this point, which is x equal to 4 and x equals -3. So this is the definition of even and odd multiplicity. What happens to the graph? So if it is odd, then it crosses the x-axis at that point, and if it's even, it's going to touch us. Any question? I'm going to move on to the next page to show you some examples. So I'm going to show you. So let's take a function g of x equals and if you look at that, all of the powers are 1. So the zeros are going to be the zeros for this function. X is 0 and x equal to 0, x equal to 1, and x equals -3. And the multiplicity. The multiplicity is the powers. So it's 1, 1, 1. So all of them are odd multiplicity. So that means it crosses the x-axis at x equal to 0, x equal to 1, x equals -3. So I'll show you how the graph looks here. So this is 0, 1, 2. I'm not drawing to scale. I'm just going to show you how the graph is going to look. So this is 0. These are the zeros of this function, and 1 and -3. Correct? So the graph goes like this. Okay, so if you look at the graph, at these points, the graph is crossing the x-axis because the multiplicity is odd. So this is how the graph, you can enter on your calculator and you can see the graph as well. However, since it's all of them are odd multiplicity, the graph are crossing the x-axis. This is the x-axis at the point -3, 0, and 1. Questions? So I'll show you next example with even multiplicity as well. So I have the next function. It is the same function with even multiplicity. So let's put 0 and I have to find the zeros. We're going to make it equal to 0. And let's write the zeros and their multiplicities. Here x equal to 0 is our first 0. And then x equals 1. And then x equals -3. Here the multiplicity is 1, 2, and 1 because the power is 1 here, the power is 1 here. So these two are odd and the middle one is even. So this is going to cross the x-axis. This is going to cross the x-axis. However, this is going to just touch the x-axis. Okay, so what does that mean? So I'm going to show you the graph here. So I'm going to plot all the zeros. This is first 0, x equal to 0, and 1, and -3. -3. So now at -3 and 0, it's going to cross. So the graph goes like this. Okay, and then it's going to touch at x equals 1. So it's going to touch and then it's going to go. It's not crossing the x-axis. However, at these 2 points, they are crossing. It just touches and then it goes. Is that clear? Okay. So that is the only thing I was going to teach in 3.2. So now I'm going to start 3.3. If you have any questions, please let me know. So in 3.3, we are going to learn about long division. So it's going to be division of polynomials. And then we are going to learn, in division, we are going to learn long division and synthetic division. And next one, we are going to learn about remainder theorem. We are going to learn factor theorem next week. Or let's see how it goes. If I have time, I can teach you the factor theorem as well. So these are the 3 objectives. However, in division, we are going to learn long division and synthetic division. The long division is just like how we do the long division for numbers. We are going to apply for the polynomials, but it's going to look completely different when you do the polynomials. However, we have to learn the terminologies. So for example, if I have to divide 143 by 3, okay, so when we do the long division, this is how we do 143, 3, and the number inside is called the dividend. And the number outside, this is the divisor. And whatever number we are going to divide the answer, for example, 3 goes into 14 4 times, and we put the 12. 4 times 3 is 12. We multiply these two. 4 times 3 is 12. And then we have to subtract, and this is the same concept we are going to use. 14 minus 2 is 2, and then we have to bring this 3 down, and 3 goes into 23 7 times. Then 7 times 3 is 21, and subtract, so we get 2. So the top one is called the quotient, and the leftover is the remainder. So how do we write the answer? The answer is going to be quotient plus remainder over divisor. The quotient is 47 plus remainder is 2 over 3. So this is how we are going to represent the answer in polynomials. So you should know what the quotient, divisor, dividend, and the remainder. Questions? Okay, so I'm going to first start doing the first problem for the long division. So use long division to solve. So we have to do 2x to the third Then I'm going to show the steps on the sides. So I have to focus really careful because there are steps I'm going to repeat again and again. So these are the steps I'm going to write it on the side. Okay. So when you are doing the long division, the step number 1 is you take the first term in the dividend and you divide that by the first term in the divisor. So these steps we are going to repeat again and again. So I'm going to write 2x to the third over 2x. So what do we get? 2 cancels out. Remember when we do division in exponents, the rule of exponents, when you are dividing, we have to subtract the powers. So 3 minus 1 is going to be 2. So this x squared is our quotient, so that goes to the top. So it is x squared. So I'm going to circle all the quotients here. Okay. So step number 2. Step number 2, you take the quotient, which is x squared, and we are going to multiply always with the divisor. The divisor is 2x minus 5. Okay, we have to multiply. So multiply, distribute. X times 2x squared is, 2x to the third minus x squared minus 5 is minus 5x squared. And we are going to write this one underneath the first, underneath the dividend, because we are going to subtract now. So I'm going to put it here. It's going to be 2x to the third minus 5x squared. And we have to, now we are going to subtract these two polynomials. So when you are subtracting polynomials, remember we learned we have to switch the signs of the second polynomial. That is the bottom one. So the plus becomes minus here, and then minus becomes plus here. So we have to switch the signs. We have to always do this because we are subtracting. So the first 2 terms always get cancelled. Now minus 11 plus 5 is going to be negative 6x squared. And then we are going to bring the next term, just like the long division I showed you before. It's exactly the same steps. Now what happens again? Take the first term, which is negative 6x squared. Just like step number 1, we are going to repeat step number 1 and divide that by this 2x, the first term in the divisor. Okay, so that equals negative 6 over 2 is negative 3, x squared over x is just x. So again, this is our quotient, so this is going to go on the top. So you put the negative 3x on the top. Okay, so again, step number 4 is same as step number 2. They both are same. You bring this negative 3x here, and you're going to multiply this with the divisor, which is 2x minus 5. So always we are going to multiply the quotient with the divisor. So now distribute this negative 3x. So we get negative 6x squared, and negative 3x minus 5 is plus 15x. Again, this always goes under the dividend. So this is the dividend now, negative 6x squared plus 15x. However, after you write, we have to switch the signs again. Okay, don't forget to switch the signs. So how do I switch into opposite? This becomes plus and this becomes this becomes minus. So first term always gets cancelled. Now we get 13 minus 15 is negative 2x. And there is one more term left in the original problem. So we have to bring 15 down here. Okay, we are not done yet because we can still divide negative 2x by this 2x. So we put negative 2x divided by 2x, which is going to be just negative 1. And this negative 1 is our quotient, so it's going to go on the top. There is one more step left, last one, because we have to multiply this negative 1 with the divisor, which is 2x minus 5. If you look at the steps, 1, 3, and 5 are the same, and 2, 4, and 6, because we are repeating the same steps. So it's going to be negative 2x and plus 5. So when you write, so that comes to our underneath here. So it's negative 2x plus 5, and we have to switch the signs again. So switch the signs. So I'm going to change this one into plus, and this one becomes negative. Okay, so these two get cancelled. 15 minus 5 is 10. So how do I write the answer? This is our, I changed different colors. This is our remainder, this is our quotient, and this is our divisor. So the answer should be in the format. The answer is Q plus R over D. So the Q is x squared minus 3x minus 1. R is plus 10 over 2x minus 5. So this is our final answer. Sorry, 1 second. Let me go back here. Okay, any questions?
No.
There are a lot of steps here. Good. Okay, so let's go to, so you get one question on the test like this. I'm going to show you next example because this is a tiny bit different because we don't have the complete polynomial. So this is our problem. Minus 33 divided by x minus 3. Okay, if you look at the polynomial is the descending order. That is the first step we have to check. Descending means it starts from the higher power, 5, 4, and it goes down. However, I have power 5, power 4, but power 3 is missing, 2 is missing. So what I have to do here, I have to put 0 for the powers which are missing. So I'm going to put 0 times x to the power 3 because there is no x to the power 3, and 0 times x to the power 2. All the missing terms we are going to put 0. Then we have x to the power 1, so we are good. And then 33. So I'm writing complete polynomial. We need this one to do the long division. Even for the next method, synthetic division, we need that. Okay, so now I'm going to show you how to divide. The steps are the same. I just put 0. So I'm going to divide this polynomial. So I'm just going to put 0 times x to the power 3. Then divide by x minus 3. I need space here, so I'm just going to delete this one. I hope everybody understands what I put here. So I need space. Okay, so I'm going to show you the steps. Just like the previous problem, we are going to repeat the steps here. So number 1, divide x to the power 5 by x. So we get x to the power 5 over x. So the answer is x to the power 4 because 5 minus 1 is 4. So that is our quotient. So it goes on the top. Step number 2, I multiply this x to the power 4 with the divisor. The divisor here is x minus 3, which is the expression outside, and then distribute. We are multiplying. So we get 4 plus 1 is 5. So now I have to write this underneath this dividend, which is x to the 5 minus 3x to the 4. And then we have to subtract. Don't forget to switch the signs into opposite. So this becomes minus, this becomes plus. So when you switch the signs, these two are going to get cancelled. Now what do I have next? I have 0 times x to the power 3. So we have to bring this one down here. But that's not going to help because 0 divided by x is 0. Then you have to bring the next 0. Again, when you divide 0 by x, you get 0. So whenever you have 0, you don't have to worry about that. Then we are going to bring this 12x down here. Okay. So now divide 12x by, now this is 12x, divide by x. So what do I get? 12x divided by x equals just 12. So this is our quotient. So that goes on here on the top. X to the power 4 plus 12. Now I have to multiply this 12 by the divisor, which is x minus 3. So it's going to be 12x minus 36. So that means I have to bring this one down here as well. So write the 12x minus 36 underneath. And don't forget to switch the sign. So this is minus, this is plus. After that, you're going to add, they both get cancelled. 36 minus 33 is going to be 3. Yes. Questions? So now we have to write the answer in the format Q plus R over D. So this is our R, this is our Q, this is our D. So it's going to be x to the power 4 plus 12, and R is 3 over x minus 3. This is our final answer. Questions? Okay. So this is all about long division. The next objective is we are going to learn synthetic division. And synthetic division is much easier than the long division. So the first example is we have to do x to the third minus 13x squared plus 46x minus 49. So we have to divide this polynomial by x minus 8. So I'm going to show you the synthetic division. The steps are we have to write only the coefficients, and then look at the given polynomial. I have all the terms 3, 2, and this is 1. So none of the terms are missing. So we are good. So we don't have to add any zeros. The step number 1, first we are going to write all the coefficients inside the box. So the coefficient of x to the power 3 is 1. If there's no number, it's 1. So I'm going to put 1. The next coefficient is negative 13, then 46, and then negative 49. And then now the divisor goes outside. Again, we don't put any x in this problem at all. We don't have to write the variable at all. So now, since this is x minus 8, the divisor is we have to switch the sign of negative 8, that becomes positive 8. That is what is going to go outside here. Okay, you always have to flip the sign when you are doing synthetic division. So now I'm going to show you how to solve. So first step, you have to bring this number down always. And then we are going to multiply 1 times 8, which is 8. And then we add them together. Negative 13 plus 8 is negative 5. Again, you multiply negative 5 times 8. So we are going to multiply. So we get negative 40. Now 46 minus 40 is 6. Again, we are going to multiply 6 times 8, which is 48. And then negative 49 plus 48 is negative 1. So this is our remainder. Okay. And this is, this x minus 8 is our divisor, D. Now, this whole thing, this 1 minus 5, 6, this is our quotient. So I'm going to show you, I'm going to erase this one. I'll show you how to write, because the quotient is a polynomial. If you go back in the previous example, its quotient is a polynomial. So how do I write as a polynomial? Well, this is our constant. Okay. This is our x term. We have to go from backwards, and this is our x squared term. So how do I write the quotient now? So the quotient is 1 times x squared, which is x squared, minus 5 times x is minus 5x plus 6. This is our quotient. So the final answer is going to be q plus r over t, where the q is, this is our q, which is x squared minus 5x plus 6, plus the remainder is -1 over, the divisor is given, you don't put the 8 here, we don't put the 8. We have to write as whatever the it's the expression or the binomial or trinomial, whatever the expression given in the original problem. That is our divisor. Question? Any question here?
Can you give another example?
Of course, yeah. I'm going to show you another example as well. Yeah. Okay. Okay, the next example I'm going to show you where we have zeros also. Okay. So divide. This is I'm doing all the problems from the handout number 4. So we have done the same problem in long division. So I'm going to show you how we are doing in synthetic division, and you can check your answer. This we have done before in the long division. So before we do that, let's write the polynomial because there are terms missing. There is no x cubed, so we have to put 0 for the x to the power 3. And there is no x squared again, so we have to put x squared is 0 plus 12x minus 33. Okay, so again, this is the same problem. So what happens here from x minus 3? We have to switch the sign to plus 3. That is going to be our divisor. So you put the 3 outside. And then now write all the coefficients inside the box. The first one, there is no coefficient, so it's going to be 1. So I put 1, -3, 0, 0, 12, and -33. So first step number 1, bring this one down here, 1. Then we are going to multiply 1 times 3, which is 3. And it goes down here, -3 plus 3 is going to be 0. You add. Then 0 times 3, which is 0. And when we add 0 plus 0, it's going to be 0. And 0 times 3, which is 0. 0 plus 0 is 0.
What's the point of even doing zero?
What's that?
Why do we even do it?
We have to. Because those are the missing terms. We have to put 0. Otherwise, you don't get the right answer.
Okay.
Then add, we have to write all the missing terms. Then 12 times 3 is 36. 36 minus 3 is 3. See, we have solved the same problem. I will show you after I complete this problem. Exactly same problem we did. So I'm going to delete all the arrows here. Now, this is the remainder is, this is the r, and this is our divisor, and this whole thing is our quotient. So in order to do the quotient, this is our constant. We have to go backwards. This is our x term, x squared term, x to the third, x to the fourth. See, if we don't put the 0 here, then we will be getting the wrong answer, correct? Now write the polynomial. 1 times x to the power 4 is x to the power 4. This 0 times cancels out, cancels out, cancels out. And then we get 12. And this is our quotient. This is our quotient. So I will show you the same problem. We have done this one before. Let's see. Do you remember this one? It's not going back. Okay. See, this is exactly what we did before. This is the quotient we got, and this is the remainder we got. But this is the longer way. This is long division. However, the synthetic division is making it much easier. So the answer is, I'm writing down the answer, x to the 4 plus 12, and the remainder is 3 divided by x minus 3. So this is our answer. Okay, so the next one, I'm going to go to remainder theorem.
So the result is the same, so I can do it.
What's that?
I said the answer is the same, so I can either way any.
Yeah,
Or it says like term I should.
I can't hear you, Farzana, because it's breaking up.
I was asking, the answer is the same for both.
Yeah, it's the same problem. It is exactly the same problem. We did in two different methods.
Method, yeah.
Yes, the first one was the long division. The second, this one is synthetic division.
So I can do either way, either.
Now, if the question, if they ask you long division, you have to do long division. I don't know if, I mean, I'm not going to see your answer, so I'm fine. Yeah, I'm not checking your answers, right? So it doesn't matter. Any other questions?
No, that's fine.
Okay, so the next one we are going to do, we are going to learn remainder theorem. And also for Farzana's questions, so so the synthetic division you cannot do for the example I'll show you. Which one is that? Mhm. The synthetic division for this problem, see, I did this one by long division. You can do that, but there is some other way that you have to, this 2x minus 5 becomes 5 over half, 5 over 2, which is a fraction. It's not, it's going to be harder. So some problems you cannot apply. I mean, you can still do that, but it's going to be longer. I'm not doing any fractions, okay? So be careful when you're doing the problems on homework or test. Some of them you can't do synthetic division. Okay, so now we are going to do the remainder theorem. So what it says is, I'm going to solve the problem and show you what that means. So we have to find the remainder. For example, I'll give you an example like f of x equals, I have 5x to the power 7 . Okay, so now we have to find f of negative 1 using remainder theorem. So I'll tell you what remainder theorem means. When I solve the problem, it's going to be easy. So you have to use, for the remainder theorem, we are going to use only the synthetic division. So before we do that, make sure it's complete, the polynomial is complete. But we have 7, the next power is 6, but we don't have 6, we have to put 0. And then we have the 5, and we don't have 4, so put, doesn't matter. Put 4 for, I mean 0 for x to the power 4, and there is no 3, so we have to put 0. And then we have 2, and then minus 1. So you have to first write the polynomial. Now, we are going to do the synthetic division, so we're going to put the box, write all the numbers underneath here, negative 3, 0, 0, 2, negative 1. However, the problem is find f of -1. So there is no x minus 1. It just says -1. So the number we have to put is just -1. We don't switch the signs here, okay? Because we are finding f of -1. Only when you are doing the synthetic division, you have to switch the signs, okay? Be careful. So you bring this one down and you do the same process, -5, and -5 plus 0 is -5, and then multiply, which is 5. 5 minus 3 is 2. 2 times -1 is -2. Then -2 comes, and then 2 times -2 is +2. Then you put the 2. Again, it keeps going. 2 times -1 is -2, so it's going to be 0. 0 times -1 is 0. The remainder is -1. Guess what? We are not dividing, we are not finding the answer for division. We are finding f of -1, which is f of -1 is this remainder. That is our answer. So f of -1 is -1. So the remainder is always going to be the functional value. When problem says evaluate using remainder theorem. Questions? Okay, so the next example I'm going to show you with imaginary numbers. Okay, so now, so this is how we evaluate. Do you need one more example or you're good? Okay, so the next one is use the remainder theorem to show that 8i is a zero of the polynomial. So what is the remainder theorem? The remainder theorem says if you get the remainder as 0, then that number is a 0 of that polynomial. So I will show you. This is number 8 on the handout. We have to show that 8i is a 0. We already learned what 0 means, of f of x equals so this is the polynomial given. We have to prove that 8i is the 0 using remainder theorem. So how do I prove this is the 0 of this polynomial? 0 means if you plug in 8i for x, the answer is going to be 0. So what I'm going to do, I'm going to use the remainder theorem. So for remainder theorem, we have to do the synthetic division. So make sure all the powers are available here. So we are good. So you put all the numbers 2, 1, 1, 28, and 64. And we have to divide this by 8i. Remember, 8i is an imaginary number, and you can use your calculator to add, multiply imaginary numbers. We have done this one before, so I'm going to show you just the steps. So bring the 2 down and then multiply 2 times 8i. You can use your calculator, which is going to be 16i. Okay. Now, when you add 1 plus 16i, you get just 1 plus 16i. It is not 17i because there is no i in next to 1. So they are not like terms. So we cannot add them together. Okay. So it's going to be 1 plus 16i. Now I have to multiply 8i times 1 plus 16i. Use your calculator again. So we get negative 128 plus 8i plus 8i. This is what you get when you use your calculator. Now when we add, these two get cancelled. We just get 8i. Now multiply 8i times 8i. we get negative 64. So when we add them, we are getting 0. If you get the remainder is 0, then 8i is our 0 of this polynomial. Questions?
So the answer is 8i.
No, you are just showing that 8i is the 0. Yeah, 8i is the 0. That's what we are. The answer is not 8i. We are just saying yes, 8i is a 0.
But how do we do it on the calculator?
Calculator?
Do I just put, for I could just put x?
I'll show you. I'll show you. Just a second, okay? See, what happens is when I go back, it's going to disappear. All my slides will go away, but it's okay. I don't need them. Okay, so now I'm going to show you how to use the calculator when you're multiplying the numbers. 1 second. Okay. So I'm going back to my calculator. Okay, so if when you're going to multiply 1 plus 16i, so you have to put inside bracket 1 plus 16. The I is the period, so you have to press second period. It puts I. Okay, and then you're going to multiply this with 8i. Always put imaginary numbers inside brackets, otherwise you will get wrong answer. So when I multiply, I'm getting negative 128 plus 8i. That's what I put on the sheet. So this is how you multiply. Is that clear?
Yeah, I just didn't know where the I was.
Yeah, we did this one before. I know we forget. That's fine. So its second period is I. Okay. So now I'm going back to my original paper. Okay. So the next, I'm going to show you another example for showing that it's a 0. I'm just trying to get some problems from online. Okay, so let's take a polynomial f of x equals okay, so we have to show that 2 is a 0. So all we have to do is use the synthetic division and divide this by 2. Just put the 2 here. And then 4, negative 28, 6. The polynomial is complete, so we don't have to add zeros. Now I'm going to show you if the remainder is 0, then it's going to be the 0. So 4 times 2 is 8. So negative 20. Negative 20 times 2 is negative 40. So we get 25. 25 times 2 is 50. So we're getting 0. That means this 2 is a 0. We have proved that 2 is a 0. Is that clear?
So it's yes.
Okay. So now I'm going to, okay, 1 second. Let my, okay. So there is only one more objective I have to complete, so I will complete them on next Tuesday. Any other questions you have?
Nope.
Everybody's good?
Can you show another example with a bigger number? Like,
Oh, okay. Let me have to go back. Okay, let me show you another example. So I have f of x. So let's see if, check if -2 is a 0, okay? So we're going to do this by -2. So put the -2 outside and the polynomial is complete. So you write the coefficients. We're going to divide this by -2. So 3, bring this 3. 3 times -2 is -6. 13 minus 6 is 7. 7 times -2 is -14. -6, -14 is -20. -20 times -2 is positive 40. When you add them, you're getting 0. So this -2 is a 0.
okay, thank you.
You're welcome. So everyone have a good day. I'll see you next Tuesday. Try to finish the homework assignments. Try labs, homeworks, review everything at the same time, okay?
Okay, take
Bye.
care.
Bye. Take care.